Okay, let's dive in. Consider this statistic for a moment. In 2023 alone, Earth lost about 3.7 million hectares of tropical forest.
Wow.
Yeah, it's staggering. That's like losing around 10 football fields of forest every single minute.
Every minute. That's hard to even visualize.
It really is, and it brings up a pretty big question, doesn't it? How do we actually, understand this level of change? How do we really grasp what's happening?
Exactly. And that's precisely why we're digging into this today. It connects directly to something you shared, information from the Indian Express, about this upcoming mission.
Ah, yes, the ESA Biomass Mission.
That's one. It feels like a really crucial step, especially for listeners trying to stay on top of major global environmental issues, and maybe for UPSC prep, for instance. It's designed to tackle this very problem of understanding.
Right, so this mission, it's launching pretty soon, isn't it? End of this month, April 29th.
That's the plan. On a Vega C rocket from Kourou in French Guiana.
Okay. And its main job, its core goal, is to create the very first detailed global map of forest biomass.
The first one, think about that. A complete inventory, essentially, of all the organic stuff, the trees, the vegetation in forests right across the globe.
That sounds incredibly ambitious.
It is. And as the Indian Express piece highlights, it's about getting a much, much clearer picture of how forests are changing and, maybe most importantly, their role in the whole carbon cycle.
The carbon cycle. Okay.
Yeah. And the tech involved, going into a specific sun-synchronous orbit about 666 kilometers up. It just shows the level of sophistication we're talking about here.
And connecting this back for our listeners, particularly those tracking for UPSC and similar exams, this hits so many relevant points. Environment, obviously, climate change, resource management.
Definitely.
And that Indian Express article really nailed the core issue. We just don't have that comprehensive global data on forest biomass right now. It's a fundamental blind spot.
A major blind spot. And when you think about how vital forests are, I mean, the numbers are pretty striking.
What are we talking about?
Well, forests soak up something like 16 billion metric tons of CO2 every year.
16 billion tons.
Yeah. And they're currently holding on to an estimated 861 gigatons of carbon that's stored in the soil, in the trees, everything. They are massive, massive carbon sinks.
Absolutely essential for balancing the climate.
Totally. But here's the catch. The thing the Indian Express source points out.
The data gap.
Exactly. We lack that detailed global picture of the biomass itself, the actual weight of all that living material.
So without knowing the weight, it's hard to know the true health or the exact climate impact.
Precisely. It's like trying to manage your bank account without knowing exactly how much money is in it. You have a rough idea, but you can't make precise decisions.
That makes sense. So how is this biomass mission actually going to fill that gap? What's the plan?
Well, the core idea is to measure changes in where carbon is stored much more accurately than before,
Right.
which ties directly back to things like deforestation. You mentioned that 3.7 million hectare loss in 2023.
Right, which apparently produced something like 6% of global CO2 emissions for the year.
Around that, yeah. So having better biomass numbers lets us quantify those impacts much more reliably.
And it's not just how much forest, but the quality too, right? I saw a quote from ESA's Simonetta Chile.
Ah, yes, the 3D imaging idea.
Exactly. She talked about creating 3D images from the top of the canopy right down to the roots. That sounds revolutionary.
It really is. That 3D aspect is key. It means scientists can look at the structure, the density, the diversity of the vegetation, not just the area it covers.
Which gives a much better idea of how much carbon is actually locked up in there.
Precisely. A much, much better idea.
So it's mainly about forests, but are there other things it will do?
Yeah, there are some interesting secondary goals. Good point. It'll also observe how Antarctic ice sheets are moving
Oh, interesting.
and help create better terrain maps, especially in areas with really thick vegetation where it's normally hard to see the ground.
Yeah.
So broader earth science benefits too.
Okay, so how does it do all this? What's the tech? The Indian Express mentioned radar.
Yep. Synthetic aperture radar, SAR. But the really special part here is the type of SAR.
Go on.
It's going to be the first satellite in space using a long-wave P-band SAR.
P-band. Okay, why is that significant? What does long wave mean in this context?
It means the radar signal has a longer wavelength.
Yeah.
And the crucial thing, as the Indian Express explained, is that this longer wavelength can actually penetrate through the forest canopy.
Ah, so it doesn't just bounce off the top leaves.
Exactly. Shorter wavelengths, like those used in many other satellites, tend to reflect off the very top layer. They see the surface.
Okay.
But P-band It's like it has better seeing through capability. It can probe deeper into the forest structure.
So you can measure carbon stored lower down in the branches, the trunks, maybe even closer to the ground.
That's the idea. It gives you a measure of the whole structure, not just the top. And critically, it can track how that structure and therefore the carbon storage changes over time.
Got it. There was an analogy mentioned something about weighing the forests. Sean Quigan?
Yes, that's a great way to put it. The P-band SAR measurements allow scientists to estimate the density and structure very accurately. From that, they can calculate the total biomass, effectively weighing it.
And once you know the weight?
Well, roughly half the dry weight of biomass is carbon. So weigh the forest and you get a really good estimate of its carbon content.
Wow. Okay, so this mission lets us track the changes in global forest carbon over time.
That's the crucial part. We move beyond static snapshots or rough estimates to actually monitoring the dynamics, seeing how the carbon balance with the atmosphere is shifting.
Which is incredibly important for, climate modeling, policy decisions, everything related to the Paris Agreement goals.
Absolutely critical, especially for anyone following these issues closely, like UPSC aspirants need to.
So the main takeaway then, the big picture for our listeners.
I'd say it's this. The Biomass Mission promises a fundamental shift. We're moving towards a data-driven understanding of global forest health and its role in climate change.
From guesswork to actual measurement on a global scale.
Pretty much. It tackles a piece of the climate puzzle that's been surprisingly fuzzy until now.
Okay, that really clarifies the significance. It makes you think, though. Here's maybe a final thought to mull over. If this mission delivers as promised, giving us this incredibly detailed biomass data, how might that actually reshape things on the ground? Like global conservation efforts or even climate change policies? Could we see totally new approaches emerge because we finally have this level of granular information?
That's a fantastic question to ponder. What new strategies become possible? What old assumptions get overturned? It really highlights the potential ripple effect of getting better data on such a critical system.
Definitely something to keep an eye on.
For sure.
Well, this has been fascinating. And if you listening in found this deep dive into the ESA Biomass Mission helpful, maybe particularly for keeping up with key environmental topics relevant for UPSC or just understanding our planet better, please do give us a like.
Yeah, and subscribe so you don't miss future deep dives.
Absolutely. And if you have more questions, drop them in the comments. We'd love to hear from you. And remember, our discussion today drew heavily on reporting from the Indian Express.
A great source for keeping up with developments like this.